right, so in this one we're going to talk about arithmetic sequences. And you can see at the top here it says arithmetic sequences are all about the patterns. So the main task is to find the pattern. Can we relate this pattern back to rate of change? Of course we can, because that's actually exactly what we've kind of been trying to make that connection over the last couple weeks here, is that the pattern, what we're seeing the change, that is going to be our rate of change, our slope in our equations. So the other big part is the word arithmetic. We may not necessarily know what that means. So arithmetic is addition or subtraction. There's actually another sequence that we call geometric, and that's multiplication or division. So we don't really get into that here. We only get into the arithmetic. So the pattern we're looking for is, what am I adding or subtracting? So with this one, so look for the pattern, addition, or subtraction. Subtraction, sorry, I know this is a little sloppy. Subtraction. If such a pattern exists, then the sequence is arithmetic. And D equals the pattern found in step 1. So D, this is the common, we call this the common difference. Common difference. So that's what D references when they say D equals. They just want to know, what is the common difference? Well, what were we adding? What were we subtracting each time? And remember, it has to be the exact same thing every time. You can't be adding and subtracting different numbers, or it's not an arithmetic sequence. So we're just going to go through and we're just going to check each one. So to go from 14 to 9, I'd have to subtract 5. So to go from 9 to 4, I'd have to subtract 5 again. And to go from 4 to negative 1, I'd also have to subtract 5. Because remember, I have the positive 4 and the negative 1, so that's actually a jump of 5. I have to take 5 away each time. So this is arithmetic. I'm taking 5 away, it's the same number, every single time. So this does work, and my common difference is negative 5. All right, so for this one, I'd have to add 4 to get from 4 to 8. To get from 8 to 16, I'd have to add 8. To get from 16 to 32, I'd have to add 16. So I am adding each time, but I'm adding a different number each time. It's doubling. Basically, it's doubling itself. It's really more like 4 times 2, 8 times 2, 16 times 2. So the next one would be 32 times 2. I definitely can see a pattern here, but it's not the pattern that I'm looking for. So with this one, this is not arithmetic. This is definitely a bit more geometric because it uses multiplication. All right, the bottom one here, I have 8 to 15. So to get from 8 to 15, I'd have to add 7. To get from 15 to 22, I'd also have to add 7. And then 22 to 29, add 7. Make sure you check each jump there, because I have seen it where it looks consistent and then all of a sudden it changes. So don't just assume after the first 1 or 2 that you are good to go. Check all of them just to make sure. So this is arithmetic, and our common difference is positive 7. You don't have to type in the positive. In fact, Alex won't let you type in a positive. It's just assumed that it is positive. All right, so down below here, we're going to practice actually finding the next couple of terms of a sequence. So we're going to find the common difference and then apply it. So the first 3 terms of an arithmetic sequence are as follows. We already know it's arithmetic. I don't have to prove that, but I am going to have to find the common difference. Okay, so with this one, what I want to know is to get from 33 to 25, what do I have to do? Well, it's going down, so I know I'm going to have to subtract. And 33 minus 25 is 8. Now, if I did that same thing for 25 to 17, I would also get negative 8. So I have to subtract 8. So we're going to do the same thing for the next one. I'm going to subtract 8 from 17. So 17 minus 8, I get 9. And then I'm going to do it one more time. So we're going to subtract 8. 9 minus 8 is 1. And that's it. That's all they want there. They just want to know what's the pattern and apply it. All right, so for this guy over here, we have another arithmetic sequence. So we're going negative 10 to negative 3. So we're actually going to be adding because we're getting closer to 0 here. So I'm going to add 7. Negative 10 plus 7 gets me negative 3. And then if I add 7 again, that's negative 3 and positive 4, so that's 3 and 4, that's 7. Because remember, they're on different sides of that equal sign. I have 4 over here, and even though it's negative 3 over here, 3 and 4 together make 7. Okay, so those integers can be a little tricky with that. So we're going to add 7 again. Boom, boom. So 4 plus 7, I get 11. And then plus 7 again, so 11 plus 7, I get 18. Alrighty, so that was our beginnings of arithmetic sequence, which directly relates to writing equations for linear equations. So go ahead and go on, Alex, and give this one a try.